guys, welcome back. This topic today we are going to discuss the directed graph, adjacency matrix, and incident matrix. Right? Already we have discussed about the undirected graph, incident matrix, and the incident matrix. Adjacency matrix and the incident matrix. This video gonna deal with the directed graph, adjacency matrix, and the incident matrix. So let me draw a sample graph what I have drawn already. For example, I have a graph like this. This is a directed graph, so I keep the same name as previous example: W, X, Y, and Z. Here I give different color as A, B, C, G, and E. I change the color pen. Okay, now already I told you adjacency matrix is a matrix between vertex to vertex. So here how many vertices are here? This is a directed graph. Now I need to draw the direction. So direction is like this, and maybe the direction is this is your own choice. You can have any direction. For example, I keep the direction like this, keep the direction like this. Okay, so now it's a vertex, matrix between vertex to vertex. How many vertices we have? W, X, Y, and Z. Here also W, X, Y, and Z. So adjacency. What is adjacency? If two vertices are connected to each other, that means if I can go from one vertices to another vertices, then the two vertices are adjacent to each other. Okay. Now WW, moreover, of course, it is not adjacent. W vertex is not adjacent to W vertex. Then W, say here, W and the X. W first row and column, right? So WX, so if we take WX, I cannot come from W to X. I cannot come to W to X, but I can go from X to W, meaning from W to X I cannot come, so 0. W to Y, sure, because the direction is like this, so I can go from W to Y. Make it the same color, so this is 0, this is 1, and WZ, there is no direct link with the W and Z, so 0. On the XW, sure, XW I can able to go because the direction is towards W, so XW is 1. I can go from X to W, so this is 1. What is this? This is 1. XX, so XX is not adjacent to XX. And XY, yes, XY I can go from X to Y, sure I can go, so 1. X and Z, I cannot go to Z, so 0. Similarly, Y and W, I cannot go. Y and X, yes, there's a link. Y and X, there's a link. I can go from Y to X. Then Y and Y is 0, and Y and Z is X. From Z, from Y I can go to Z, so Y and Z is 1. And from Z I cannot go anywhere because the arrow mark only one incident, that is towards the Z. That means from Z I cannot go anywhere else, so 0, 0, 0. So this is the data graph adjacency matrix. The same graph, same graph, I draw the incident. incident matrix. What is incident matrix? It is a matrix drawn between, I think it's little size, drawn between vertex to edges, right? So here I draw the vertex. I go here, okay, I draw the vertex between, it is a matrix between vertex to edges. What is the vertex we have here? W, X, Y and Z. And I redraw the graph again. I redraw for convenience. This is W, this is X, this is Y and this is Z, and this is edge A, edge B, edge C, edge D, edge E, and we have the direction like this, and B is like this, and C also like this, and D is in this way, okay, right? Now how many edges we have? We have A, B, C, D and E, okay. W and A. So here what you need to keep in mind, this is a any vertex, okay, any vertex. If a edge is incident to this vertex, this one V, okay, so that means we should take -1. In other words, simple language, if any edge comes towards the vertex, you should take -1. If any edge goes away from the vertex, you need to take +1, okay. Keep this is the rule, keep this in the mind and come here. WA, with respect to W, the A comes or goes away. A comes to W, so comes to W means this one, that is A comes to W, that is -1, okay. Then WB from W, so B goes away from W, so +1. And C is not related to W, I mean C is not incident to W, and D also not incident to W, and the E also not incident to W. Then XA, with respect to X, A goes away from X, so 1. So you see here, A is going away. See here, see the arrow mark, A is going away from X, so XA is 1, and XB, B is not connected to X, and C also goes away from X. D comes to X, so -1, and E is not related. And YA, so Y is not related to A, and Y is B, YB, B comes to Y, so -1, and C also comes to comes to Y, so -1, and D goes away from Y, so +1, and E also goes away, so +1. For Z, E is coming to Z, so coming means what? -1. The rest of the edges are not related to Z, okay. This is the incident matrix of directed graph. So in this, only thing you need to remember, any edge comes to the vertex, we need to take as -1. Any edge goes away from the vertex, you need to take +1. Based on these two rules, we need to form the matrix, incident matrix, okay guys, simple. Okay, see you, have a great day.